We have made it to chapter 2. And in chapter 2, we are going to be looking at sets, the nature of sets. And I think that you're going to like this chapter. It's going to be very different. And for most of my students, they like this. It'll be um, a little bit less intense than the last chapter. So let's dive into section 2.1. This section is pretty heavy on vocabulary. So just know that it's a little bit different, very different from the last chapter. But we are going to start out by talking about set notation. And in order to introduce that to you, I decided that I would try to introduce it with topics that maybe you are familiar with. So I thought we would introduce set notation by looking at the Southern Baptist Convention. And so to introduce sets, I pulled out some churches in the Southern Baptist Convention. So this is Sweetwater Baptist Church, which my husband used to pastor in rural Alabama. And this is First Baptist New Orleans, which several of you are familiar with. This is just a cute little country Baptist church that I found a picture of on the internet. And according to some statistics that I Googled, there are 51,379 churches in the Southern Baptist Convention. Okay, so now we can write all of these into one big set, and we will call that in set notation. So let's talk about how we might write that in mathematical form. So when we consider this, the 51,379 autonomous Southern Baptist churches, we can talk about them with set notation. And we do this with starting out by talking about a capital letter, okay? So we're going to give them a capital letter S. So I'm just going to call them the set S. And so we give every set a capital letter, and then we will have an equal sign. The equal sign says, how are you going to define your set? Well, I'm going to define my set in the following way. I'm going to use brackets. So the brackets are important because inside of that bracket are all of the elements of my set. I'm going to either describe the elements or I'm going to list them. And so in this particular example, I've given you a description of the elements of my set, and I've just basically said it's all the Southern Baptist churches. Okay, so, but those brackets are containing my set. So the big things from this slide is that you need a capital letter. You have to have that equal sign to tell you how you're going to define your set. And then you have those brackets. So those are important parts of set notation. So let's talk about this set S of Southern Baptist churches. We have a couple of different ways that methods, as I said in the last slide, that we will list out all of the elements of this set. So the first way that I told you is the description method, and that's where you describe the elements of the set. So that's the description method. Now you can also have a roster method. So the roster method in that case is where you actually list out all of the elements and members of the set. So if I wanted to, I could list out all 51,000 some odd members, which I'm glad that I'm not going to do that, but I could. And so the way that you would do that, each church is an element of the set S. And if you would notice that all of the elements in the set are separated by commas. So that's another part of set notation that you need to be aware of, is that you separate them by just a plain little comma. So that is another part of set notation. So let's look at a couple of examples from your homework of how this is going to look, of what you're going to have to do. So one of the examples, you'll be asked for several of your problems to specify the set by roster. And so they're going to give you this problem that they'll give you a set, and it'll say A is equal to the distinct letters in the word church. Now, distinct means that they're the different letters. So the letters that are distinct and different from each other. So that's the only letters that they want in the set A. Okay. So let's take a look at that. We're going to start building our set. So I'm going to look at the first letter, C. So that's going to have to be in my set A. So I'm going to start building my set A. So remember that my set A over here. So I'm building my set A, and it has, I'm going to have the C, comma, and then I need an H because that's a different letter. So there's my H. I need a U because that's a different letter. I need an R because that's a different letter. But I do not need a C or another H because those are already had. They're not distinct. So I can't tell these last two, C and H, I can't tell them apart from these two. So that's why I don't repeat them. So these are the distinct letters. Now, here is where in WebAssign, this is how you enter this in, and this is where it gets tricky, okay? So in WebAssign, all that they want you to put in WebAssign is exactly what you see right here. You're just going to put bracket C, comma, H, comma, U, comma, R, bracket, okay? So just like you see it right here. If you were to put A equals, they're going to say that it's wrong. All right, so only put this bracket CHUR. So they want you to specify the set. They only want you to give them the actual set. Okay, so so just know that. That's where watching this video and taking these notes in WebAssign, that is how you want to put your answer. Okay, all right. Now, let's look at another, no more extra spaces either, so don't put extra spaces in here. C, comma, H, comma, U, comma, R. You got it? All right. I'm trying to save you some headaches from that computer. Okay. All right, let's look at another one. B is equal to the counting numbers containing only ones. Enter only the first four values of this set. All right, so let's think about that. In WebAssign, how is that going to look? So counting numbers is like how you count, 1, 2, 3, 4, 5, 6, 7. So I want the counting numbers that only contain ones, and I want the first four of those counting numbers. So what in the world does that mean? Well, I'm going to have my opening bracket. I'm going to have 1, obviously. And then the next counting number that only contains ones would be 11. Can you think of the next one? It's going to be 111. And the next one, 4 ones, 1,111. Okay, so it says Enter only the first 4 values of this set. So they only want the first 4 values. So this is where you have to read the directions very carefully. Only give them what they want and no more, no less. Okay, so this would be like the answer for this particular question. All right, hopefully that'll help you get through some of these questions on your homework. Okay, so on this example, this is going to be to specify the set by description. And this is going to be a matter of interpreting how you describe this set by using the word between. Okay, and I'm going to try to explain this by using a church example. Hopefully it won't go bad. But the best way that I have come to find this out is I want you to imagine that this is a church pew of people sitting in one big long pew. And have you ever been like to one of these conventions or something like that where you have to like take a vote or something like that, and the people who sit on the ends, have you ever had to be one of those people that sit on the end and you have to take a vote and everything has to be passed down to the end, and that person on the end, like you either love to be that person on the end or you hate to be that person on the end. You know what I'm talking about? Because the person on the end has to gather all the ballots together and you can't even enjoy anything because you're just like constantly like looking down the pew and like waiting for everybody. Have you ever been that person, or have I been the only person that has done that? Okay, so it kind of like robs you of your joy. Now, so, you either love to be that person or you hate to be that person. Or it could be that if you got lucky and you went to one of these highfalutin churches, that's one of these South Alabama terms, highfalutin. So if you went to one of these highfalutin churches where they had ushers, and so then everybody on the pew, you don't have to have a job. So even these people who sit on the ends, you don't have to worry about it because there's going to be an usher out here. And so you just get to be like a normal person. Mr. 95 and Mr. 5, they just get to be a normal person and they just get to pass their ballots to the usher, on the end, and they just get to participate and just be a normal person. And so I always liked that because then you just kind of get to fade into the background and you just get to be a normal person. Okay, now this is what I'm talking about. So you have 2 options here. We have the multiples of 5 between 5 and 95, or the multiples of 5 between 0 and 100. So basically, we want to describe this entire set. So we want to make sure that we don't leave anybody out. We want to make sure that even Mr. 5 and Mr. 95, we want to make sure that they get included in the description. They cannot be left out, okay? If we were to choose this first description, poor Mr. 5 and Mr. 95 would get left out because it's between 5 and 95. And it's kind of like they are the collectors of the ballots and they are having to do all of the work on the ends of that poor pew. And they're having to do all that work because that's what we're saying here. We're saying this is the multiples of 5 between those 2 numbers right there. And they're being left out of the description. But if you say the multiples of 5 between 0 and 100, that is like you've got 2 ushers on the outside. And then everybody, including great old 5 and 95, they get included in the description. And then everybody is happy. Okay? I hope that made sense. You just have to make sure that these words like between, you just have to make sure you include everybody in the description. And so you got to make sure those people that are sitting at the end of the pews, they have to be included in that description. So just make sure you don't leave them out because nobody wants to be left out in God's family. Okay? We don't want to leave anybody out in God's family. All right. Okay, now we have another definition of elements. And so the set S, we have the description method here, and then we have the roster method here. So we have this notation right here that Sweetwater Baptist Church, and we have this funny looking little E. That is the notation that Sweetwater Baptist Church is an element of S. Okay, so that's how you do a shorthand. So that funny looking little E is saying that Sweetwater Baptist Church is an element of S. So that's what it means to be a member or an element of the set S. Okay. And then, oh my goodness, Hope Methodist Church. Nope, 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 nope. We do not have any Methodist churches in S, okay? So notice how we write this, okay? So we write an E with a slash through it, okay? So it's very, yes, very slashy like that. So we just E with a slash through it. So make sure that you know that is how you write that Hope Methodist Church is not an element of S. Okay, so you need to know how to write element and not an element and how to pick those out of a list. All right. Another set of definitions talks about well-defined or not well-defined. So if you had the set A of the 50 states of the United States of America, if it is a well-defined set, then pretty much everybody, so you should be able to Google that answer. Okay, that should be an answer that you should be able to Google or everybody should be able to figure out. Set A is well defined. You should be able to figure that out. We can look that up and figure that out. Now, set B or F, okay, set F, foods that I like. That is not well defined. That is not an answer that you can Google, okay? That is not well defined. If you can't Google it, it is not well defined. So just know that is how I determine if it is well defined or not well defined. Okay, so if it is understood by everybody, it is well defined. If it is not, if it is up for debate, it is not well defined. Now we're going to talk about set notation and set builder notation. So we're going to look at the set D of men. So this describes what the elements are made up, how the set is going to be made up. So this is the set of all men. And then you have this straight line. The straight line means such that, okay? Such that, and then we're going to have a description. And so the description is such that the men are deacons at Sweetwater Baptist Church. Okay, so this, if I wanted to read this, I would say the set D of men, of all men, such that the men are deacons at Sweetwater Baptist Church. So that's how I would read this set. Okay, now let's look at set T down here. This is the set of all x's such that x is less than or equal to 10. Less than or equal. This is the less than or equal to sign. Less than or equal to 10. So that's how you would read this particular set. Okay, so that is set builder notation. Now this is a very important slide, and this is going to talk about famous mathematical sets, and you're going to want to make sure that you really take good notes on this slide and that you understand these particular sets. So we're going to start out with the natural numbers. These are also called the counting numbers. And these numbers start with just like how you normally count, 1, 2, 3, 4, 5, and it just keeps going on and on forever. So that is known as the set N of natural numbers. It's a capital N. Sometimes you see the N written a little funny, and but that's the natural numbers. Okay, so we start with 1 and keep going. Now we're going to build on each set. So the next one is if I take the natural numbers and I add 0 to it, you get the whole numbers. So the whole numbers includes all of the natural numbers, and it also includes 0. I remember that by saying whole, and I remember that the whole is 0. So that's how I remember it. It's a capital W, whole, and the 0. That's how I remember it. Okay. So when I go from, and I keep building, if I get bigger from the whole numbers, my next bigger set is called the integers. So if I take the whole numbers, which includes the 0, and I add in all of the negative numbers, if I put in all of the negative numbers, which the negative numbers goes in this negative direction forever and ever, then I get the integers. The integers, we will call that one is known as set Z. The integers is always known as set Z. I used to know why. And for right now, I can't exactly remember why. I'll have to look it up. Okay, so that's set Z. Then if we go bigger from the integers, we're going to go to the rational numbers. The rational numbers, if you notice, it takes all of the integers, and then in between all of these integers, you have like fraction numbers and you have decimals in both directions. So the rational numbers goes in between here. Okay, and that's a very big set. All of these are huge, infinitely large sets. They're all infinitely big, meaning they go on and on forever. So the rational numbers is known as set Q. These are always, like anytime you see rational numbers, it's going to be the set Q. Anytime you see the integers, it's going to be the set Z. Anytime you see the whole numbers, it's the set W. And the natural numbers is the set N. Then you also have irrational numbers. Irrational numbers are going to be a different set. So irrational numbers are not going to be included in these sets, and we will talk about them at a different time. This is homework number 7, and a similar problem to homework number 7, and it's one that a lot of my students have questioned me about over the years. It's not very difficult, it just looks different, and so I thought I would put this in here and go over it with you. It says, write out in words the description of this set, and so yours is going to look a little different than this, but it's similar. So x such that x is an element of n and x is, and you see what it says here. Okay, so then it has this box that says the set of, and then it gives you a drop down menu, and then it x such that x is, and then you have another drop down menu, and then 7. And then it says list the set in roster form. So let's figure out what in the world they're talking about, okay? So basically, they want you to give the description of this particular set. So when you click, so the first thing you're going to do is you're going to click on this little drop down arrow, okay? When you click on the drop down arrow, it's going to give you a whole bunch of different numbers, which is going to correlate to those numbers that we just talked about, all of those sets. Now, where is this coming from? Okay, so this is the description in words of this sentence, this mathematical sentence right here. So they are building the description of this set. So where does this come from? Well, this comes from that right there, that symbol. So if you remember from the last slide, what does that N represent? Which set did it represent? Well, the N represented the natural numbers. So you would choose natural numbers. And so when you choose that, it's going to fill in this blank with natural numbers. Now, if this was a Z, if your example in WebAssign says Z, you would pick integers. If yours says W, then you would pick whole numbers. If yours says Q, then you would pick rational numbers. So it depends on whatever your homework problem says. Everybody's is a little different. Okay, mine says N, so I picked the natural numbers. So it's the set of natural numbers X such that, remember this little straight line means such that X is, so then you want to click on this little drop down again. X is, now where is this coming from? All of this is coming from this little symbol right here, right? It's coming from that symbol. We have to match up that symbol. Now, if it's been a really long time since you have had math, let's go over all of these symbols. Okay, so I'm going to give you all of these symbols very quickly so you can take notes because it may has been a really long time since you've had this. So that's your less than sign, less than or equal to, greater than or equal to, and then equal to. Okay, so just remember that you have less than is a strictly less than. Okay, so this means it can be also be equal to whatever number it is, less than or equal to. Greater than is strictly greater than. And then greater than or equal to means that it could equal to that number as well. Okay, so if I match these up, this says that it is less than. So let's go ahead and mark that one. Now, then it says so that would be everything that you would need for the first part of this in WebAssign. Then it says list the set in roster form. So the set of all numbers in my natural numbers that are less than 7. So now we have to think about what are my natural numbers. Okay, my natural numbers are my counting numbers. Do they start with 1 or do they start with 0? Go back to your notes. So remember the natural numbers start with 1. So counting numbers, natural numbers start with 1. Okay, so we're going to start with 1. We're going to go 1, 2, 3, 4, 5, 6. Are we going to include 7 or not? That's my question. So this says that we are less than 7. If you are less than 7, that means you cannot include 7. That's like 7 is sitting at the end of the pew and has to serve duty. Okay? We are less than 7. If we are less than or equal to 7, then we include 7. But if we are strictly less than 7, we have to stop at what number? We have to stop at 6. So let's look at the roster form and make sure you understand that, okay? So because we are less than 7, my numbers are 1, 2, 3, 4, 5, and 6. I cannot include 7 here because this is strictly less than 7. If this was less than or equal to 7, then I would include 7 in this, okay? So that's the difference here. So you need to look at your example and you need to decide if your example said less than or equal to, then you would have to also include 7. Okay, and you may have another, I mean, you're going to have whatever number it says for you. It may say 10 or whatever number it is. Now, what if this was a W for a whole number? If this was a whole number, I would have had, like if this was the same exact problem and it said X is an element of W such that X is less than 7, then I would have also had to put a 0 in here. 0, 1, 2, 3, 4, 5, and 6. Okay, so just know that, you know, they're depending on which set you have. That's why you need to use those notes from the previous slide. Okay, so that's where this particular problem can be a little bit tricky. Now let's talk about the empty set. You wouldn't think that there would be so much to talk about the empty set. It's a set that is empty. But there is a lot to talk about the set that has nothing in it. So let's talk about it. It is this set A. You can have a bracket. There's a lot of ways to write it, believe it or not. You can have a bracket with nothing in it. Okay, so just a blank little bracket spot there. Poor little empty spot. Now, we can also call this the empty set or the null set. You can call this null set. So this is also written as this empty set with a 0 with a slash through it. Okay, so that's another way that it is written. So that's another, that these two things are the same. Okay, so that's another thing that is written. Now, I want you to see that here's 3 different things, okay? So, the first one is the empty set. Okay, that's the empty set. The second one is the number 0. So, they are different. All right, so they are different. Now, this third one is also different. This is different as well, okay? This is a set with one member, and that one member is the empty set. Okay, so just know that you can have 3 different things that they all look very similar, and you would think they're all the same, but they're all different. All right, and then so just know that, and like on your homework, it can be tricky because they may have all of those different things in there. We're getting closer to the end. We're talking about cardinality. Cardinality is counting. So when you look at the set A, which has 1, 2, 3, and 4, the cardinality of set A is the number of elements of A. So the way that we write that is you put A in these two little sticks right here. It's almost like the absolute value of A, but it's noted as the cardinality of A. When you see that, that's pronounced the cardinality of A. They want to know how many members are in A, how many elements, which there are 4 elements in A. So if you see A in those sticks, that's what they want to know. How many elements are there? There's 4 of them. So looking at B, if I wanted to know the cardinality of B, and B contained NOBTS, then the cardinality of B would be 5. Okay, because there's 5 letters, so and there's 5 elements. We're going to look at 2 more definitions, and these 2 definitions are they're similar, but they are distinctly different. Equal versus equivalent. So first is equals. A equals B if they contain the same elements, and then A is equivalent to B if they contain the same number of elements, okay? If they contain the same elements or the same number of elements. So one deals with cardinality, one deals with the actual elements themselves. So let's actually look at example here. So we have A, B, C, D, and E. Now, when you look at this particular setup right here, I want you to kind of look at these numbers here. So A is the set containing 21. B actually contains a mathematical operation, 20 plus 1. Okay, and then C is 20 comma 1, D is X comma Y, and E is 21 written out in words. All right, so what I want you to see is we want to talk about which ones are equal and which ones are equivalent. Now, just because this one, so we have 21 here. Now, if you were to do the math on B, what would it be? It would be 21. So this actually, when I do the math, this is the same element as A. So A and B actually are containing the same element. All right, even though this is written in a mathematical operation, it's just disguised in a different format, but they are the same exact element. Similarly, E is just written, the word written out, but it is the same element. Okay, so it's almost just like in previous examples when I said Sweetwater Baptist Church or I said SWBC. I was referring to the same church, right? I just wrote it in a different format, but it was referring to the same entity, the same church. And you knew that. As well as the same thing here. 21, 21, 21. We're referring to the same element. We're just writing it 3 different ways. Okay, so that is the same element. So when we talk about equals, these are equal. A, B, and E are all equal to each other. Now, they're the only ones that are equal to each other. So those are the only ones equal. Now, equivalent, we actually have to go through and figure out the cardinality. So let's talk about the cardinality. The cardinality of A, which is how many, remember cardinality is how many elements? There's 1 element in A, 1 element in B. C has 2, there's 20 and then 1. D has 2. and E has 1. So which ones are equivalent? And remember, the way we write equals is A equals B equals E. Okay, so that's equals. But equivalent, we write with this double arrow. We write that. That's how we write equivalent. So the ones that are 1s are going to be equivalent. The ones that are 2s are going to be equivalent. So A is equivalent to B and E. So notice how they're written with those double arrows. And then we have C and D are written with that they are equivalent. You've got several on your homework that are like this. All you have to do is just kind of just go through just like what we did here. So they're not difficult. You just have to just kind of, look through them. Yeah, that's all you got to do. All right. Last slide, and then we are done. The last topic is subsets, okay? So a subset, and we have kind of done this, we've done subsets. You didn't realize you were doing subsets, but we've kind of tackled this idea in chapter 1 even. But let's say that we have A, which contains the set 1, 2, and 3. We're going to try to make every subset that we possibly can. So a subset is just a smaller set that contains elements from A. Okay? Now, subsets of A. Please listen. The empty set is a subset of every set. I'm going to say it like 2 more times. The empty set is a subset of every set. Write it down. Everybody got it? The empty set is a subset of every set. You need to know that. The empty set is a subset of every set. Okay, hopefully you got that. Now, then, we can make a set of each of these elements by themselves. One element in each set. That's a subset, okay? Then we can make, what can we make with 2 elements in each set? Okay, so then I'm going to make subsets that have 2 elements. Well, I can make 1 and 2, and I can make 1 and 3. I can also make 2 and 3. All right, so those are all of the elements, those are all the subsets that I can make that have 2 elements in them. Okay, that's every combination of those 3 numbers that have 2 elements in them. Then I'm going to make every subset that has 3 elements, and that is just going to be the 1, 2, and the 3. So there's no other combination. You can move them around, but moving them around is not distinct. Okay, I mean, so like to say 3, 2, 1 is no different than 1, 2, 3. Okay, so that's the same set. So this is all of the subsets of A. This is all of the subsets of A. So now if you were to count them, there's a total of 8 subsets. Now this is very important. It will save you a lot of time if you will just know that I'm going to give you a formula that's going to help you. The total number of subsets, you will thank me for this, I promise, is 2 to the n power, where n is the number of elements in the set. 2 to the n power, where n is the number of elements in the set. So 2 to the 3rd power, which means if you were to take your calculator out and you were to say 2 to the 3rd power and press enter, you would get 8 because there's 3 elements in here. If you were to try to figure out, like if you had a set that had 4 elements in it, and you wanted to know in your homework problem said, how many subsets would you have If you had 4 elements, all you have to do is get your calculator out and you have to just put 2 to the 4th power and press enter, and then you would get the total number of subsets. And then you don't have to go through and write all of that out. If you had 10 elements, you would just say, get your calculator out, 2 exponent 10, and you press enter. It's wonderful. It's such a great, great time saver. I promise you. It's wonderful. Okay, so that's a wonderful, wonderful formula that you will want to use. I promise you will want to use it. It's on your homework. Okay, use this formula. Use it. It's wonderful. All right. I hope that helps you, and that is section 2.1. Good luck.